Okay, Kyana, I'm using my phone to record this, so it's probably not going to be as good as the lab, or I mean, as the, as when I use the iPad. But here I have drawn the X and Y axes in red, and then I have vector A coming from the origin. Now, in yours, you had vector A coming from a different point on the x-axis, but in the lab it says to draw it from the origin, and then you're supposed to draw vector B coming off of vector A, which is what I have up here in this triangle. I know it's not clear, I'll explain it though. And then the resultant vector coming from that, so it goes from the tail of B, or the end of B to the beginning of A. So since vector A is on the x-axis at 0 degrees, and then vector B is 110, which makes sense because it's in this second quadrant, it's just past 90 degrees. And then the resultant vector is 229 degrees, which makes sense because it's in the first, second, third quadrant, so it's just past the 180. Now, it says in your data table that you're supposed to come up with the X and Y components. You probably remember this from last semester, and this has to do with a little bit of the trig that we talked about last time. I won't go into detail about this because you don't really have to know how you got it. But if you have a vector that is at a diagonal, then it's got an X component and a Y component. And to get the X component, you multiply the hypotenuse, or whatever that vector's amount is, by cosine theta. So theta is whatever angle it's at in reference to the x-axis. And then for the y-axis, you do the hypotenuse, or whatever value the vector has, times sine theta. I was looking at your table, and for the x component of A, you've got 140, but remember in the lab it says that mass is not a vector, and you have to multiply by 9.8 because that's gravity, 9.8 meters per second. So when I do that, I get 1372. And so you'll need to do that, multiply each of those amounts of grams by 9.8 so that you can get it in newtons. And then A is at 0 degrees, so you'll do that, like you'll fill this out where it'll be X equals the 140 times 9.8 times cosine of 0 degrees, because vector A is at 0 degrees. And then you'll do that for, like, you'll do the same thing but change cosine to sine for the y component. And then you'll do that for vector B and for vector R. And you'll fill that out in part 3 of the table. As for the magnitude, I think they want whatever mass times gravity is. And as for direction, I think they just want, I don't know what they want. I think they just want whatever direction it is in terms of the X and Y planes. So A would be going to the right, and B would be going, so A would be going east, and B would be going northwest, and resultant would be going southwest. I'm not done yet, but I won't be able to send it if I make it too long. So this is part 1.